In February 2025, scientists detected an asteroid heading our way. If it hit, it would create a crater the size of Manhattan and unleash a shockwave strong enough to flatten everything within 30 miles. Uh-oh, I'm out of here. Well, luckily for now, we're in the clear. But the threat is coming back in 2028, and this time, everything might change. You see, in 2025, NASA announced that an asteroid, called 2024 YR4, had a 3.1% chance of hitting Earth in 2032. Now, in asteroid terms, that's high enough to sound the alarm. The asteroid itself is not the end of the dinosaurs level, but it's big enough to level a city. The rock is about 130 to 300 feet wide. That's roughly the size of a large jet. Now, if something that size slammed into a populated area, it wouldn't end the world, but it would result in a very, very bad day. And still, no one panicked, and scientists weren't scrambling for bunkers. Because when we first spot an asteroid, we have to work with limited information. It's like seeing a plane high up in the sky and trying to guess exactly which gate it'll park at. That's why astronomers rush to gather more data. The asteroid itself seemed pretty ordinary. It was rocky, not some rare metal thing. It was first spotted in late 2024 by an observatory in Chile during a regular skyscan routine. There's this group called the International Asteroid Warning Network. Their job is to keep an eye on space rocks that might try to ruin your day. And back on January 29, 2025, they announced that the chances of that particular asteroid hitting Earth had gone over 1%. Now, 1% might not sound like much, but that's enough to make scientists start worrying. The impact risk for 2024 YR4 reached its highest point on February 18, 2025. That's when scientists calculated a 3.1% chance it could hit Earth. But by February 23, after more observations came in, that possibility was essentially ruled out completely. The asteroid's Torino scale rating, which is used to categorize the impact risk of near-Earth objects like asteroids and comets within the next 100 years, was lowered to 0. It means it's no longer considered a threat to Earth. Well, for now. But scientists still keep tracking it, and based on additional data, there is now a 4% chance it could hit the Moon instead. If that were to happen, it would be on December 22, 2032. Right now, the asteroid is expected to pass about 5,600 miles from the Moon's surface. However, there's a very large uncertainty range, about plus or minus 46,000 miles. So it could easily miss the Moon by a very large distance. The last time we had something this dangerous was back in 2004, with an asteroid called 99942 Apophis. Back then, it had a 2.7 chance of hitting Earth in 2029. People were sweating. But after better observations, scientists ruled out the impact. This time we actually passed that old record. 2024 YR4 is currently heading out toward Jupiter's neighborhood and won't swing back close to us until 2028. And that's when everything might change. If the risk jumps above 10%, the IAWN will send out a formal warning to the United Nations. They'll tell countries in possible impact zones to maybe start preparing, because if we talk about the damage… Admittedly, this asteroid is not the 6-mile-wide monster that wiped out the dinosaurs 66 million years ago after hitting Earth. This here asteroid is in the city killer category. It sounds dramatic because it is, but it's not some global extinction stuff. The real problem isn't just its size, it's its speed. If the asteroid hits, it could be moving nearly 40,000 miles per hour. That's like flying from New York to LA in under 5 minutes. But still, the most likely scenario would be the asteroid exploding in the air before even hitting the ground. That's called an airburst. But if the asteroid is on the bigger end of the size estimates, it could actually reach the surface of our planet, slam into the ground, and make a crater. So that possibility's still on the table. As for where it could hit, the possible impact zone covers a huge area: Eastern Pacific, Northern South America, the Atlantic, Africa, the Arabian Peninsula, and South Asia. Raise your hand if we left you out. Keep in mind, though, that it's way too early to make life decisions based on that. So, no packing up and moving yet. Besides, we're not sitting here helpless. In 2022, NASA pulled off the DART mission, where they literally smashed a spacecraft into an asteroid to nudge it off course. And it worked. DART stands for Double Asteroid Redirection Test. It was built for NASA's Planetary Defense Office. They wanted to know if we could push an asteroid just enough for it to miss our planet. So they launched a spacecraft in November 2022, and it traveled through space for about 10 months. The plan from day one was to crash it. The target was a small asteroid moon called Dimorphos, which is about 530 feet across, the size of a large stadium. Dimorphos orbits a bigger asteroid called Didymos. The two of them just circle each other out there in space. What's important is that neither of them was threatening Earth, so this was a safe test. Now, DART was basically a heavy spacecraft with a camera and a smart guidance system. The strategy was to hit Dimorphos at about 14,000 miles per hour and let the force of that impact slightly change its orbit. In the final stretch, the spacecraft guided itself. It had to figure out which rock was which, lock onto the smaller one, and adjust its path without anyone steering it in real time. When it hit, the onboard camera sent back close-up images right up until the moment of impact. Then the signal stopped because the spacecraft had done its job and smashed into the asteroid. There was also a small Italian CubeSat that separated earlier and stayed back to photograph the collision and the resulting debris cloud. Those images showed a huge plume of rock and dust blasting out into space. Well, after that, astronomers around the world started measuring the orbit of Dimorphos very carefully. Before the collision, it took 11 hours and 55 minutes to circle Didymos. After the impact, it took 11 hours and 23 minutes. That's an impressive 32-minute difference. The interesting part was that the spacecraft alone wasn't responsible for all of that shift. When DART struck the surface, it threw tons of rocky material outward. All that rock and dust blasting off gave the asteroid an extra push, stronger than the spacecraft alone could have done. Scientists later realized that Dimorphos wasn't a solid chunk of rock. It was more like a loose pile of rubble held together by gravity. That probably helped produce more debris and a bigger push. So if we ever face a denser, more solid asteroid, the same technique might not have the same exact effect. That's why scientists are also looking at other ideas, like using lasers to heat up part of the asteroid so bits of rock fly off and slowly push it in the opposite direction, like giving it a tiny built-in rocket. Or they could place a spacecraft close to the asteroid and use its gravity to slowly pull it off course, like a small tugboat guiding a huge ship. Or if things got really serious, use a nuclear blast as a last resort shove. Despite the success of the DART mission, NASA says we do not have a ready, reliable system that could stop a city-killing asteroid if one suddenly shows up on a collision course with Earth. The danger isn't the giant dinosaur-level asteroids. Those are huge and easy to track. Neither is it tiny rocks that burn up in the atmosphere all the time. It's the middle-sized ones, around 500 feet wide. Scientists estimate there are about 25,000 near-Earth objects in that size range moving near Earth's orbit. So far, we've only found about 40% of them. That means most of them are still out there, and we don't know exactly where they are. The problem is they're dark. Most don't reflect much sunlight, so even powerful telescopes can miss them. To help fix that, NASA plans to launch a new space telescope called the Near-Earth Object Surveyor. Instead of looking for sunlight bouncing off asteroids, it'll look for heat. Even a dark asteroid absorbs sunlight and gives off heat, and that's easier to see in infrared. Astronomers just spotted an asteroid roughly the size of 8 football fields. It spins so fast that it completes a full rotation in just under 2 minutes, which makes it the fastest asteroid ever found in its size class. If this bad boy hits Earth, the consequences will be, well, let's just say everyone will notice. You think? Scientists caught MN45 using early data from an observatory on a mountaintop in Chile with a 3,200 megapixel camera. Ooh. It will be scanning huge areas again and again for 10 years to catch what moves, what flashes, and what wasn't there yesterday. The SuperCam takes an image every 40 seconds, and that's how it noticed MN45. The same equipment recently caught around 2,000 other asteroids, but our hero definitely stands out. Now, an asteroid spinning this fast probably didn't start life as a calm, normal space rock. Scientists think a past collision could have smacked it hard enough to spin it up like a toy top. And if that impact was violent enough, MN45 might not even be the original asteroid, but a fragment that broke off from a much larger parent object, basically a piece of a bigger monster that got shattered long ago. Spinning fast in space isn't just a flex, it's dangerous, because rotation creates stress, and stress tries to rip an asteroid apart. If a space rock doesn't have enough internal strength, it doesn't stay one object. It fragments into smaller pieces like a cookie that cracks when you twist it too hard. That's why most asteroids never spin this fast. Most of them aren't solid boulders. They're rubble piles, basically space gravel held together by weak gravity, like a floating clump of broken rocks. Astronomers have a kind of speed limit for asteroids. In the main asteroid belt between Mars and Jupiter, a typical rubble pile asteroid needs to rotate more slowly than about 2.2 hours per full spin to stay intact. Anything faster than that starts entering the danger zone. So if an asteroid spins faster than this limit, and it's still big, that's a massive clue. It must have unusually strong material inside, like solid rock or something even denser. Because if it were weak and crumbly, like most asteroids, it wouldn't be spinning. It would already be a cloud of debris. The good news is that this hard rock asteroid isn't coming for Earth. It's at a safe distance from us, up in the asteroid belt. But its existence screams something terrifying. If something this big and this extreme stayed unnoticed until now, what else could be hiding out there? Perhaps the real threat isn't one record-breaking spinner, but a blind spot. Some simulations show that there could be a whole swarm of hidden city-killer asteroids hanging around Venus like cosmic pickpockets. As you can guess from the name, these asteroids are large enough to destroy an entire city. The reason they're so hard to catch is that they hide in sunlight. From Earth, the area close to the Sun looks bright and washed out, which makes it easy for objects near Venus's orbit to blend into the glare. It's like trying to spot a black cat in a dark room when someone shines a flashlight straight into your eyes. And this is where it gets personal, because humans love pretending we control space. But these Venus-hiding asteroids don't care. Their orbits can shift slowly over time because of gravity nudges and long-term motion. And that means one of them could eventually get pushed onto an Earth-crossing path. Not today, not tomorrow, but someday. And in asteroid terms, someday always arrives faster than people expect. Now let's talk about a completely different kind of dangerous asteroid, Bennu. Now Bennu isn't a solid rock freak like MN45. Bennu is a rubble pile, a loose, clumpy near-Earth asteroid about 1,600 feet wide. It's famous because NASA actually went there. The OSIRIS-REx mission grabbed samples and brought them back to Earth. And what scientists found inside was straight-up mind-blowing. There were life-linked elements, including sugars like ribose and glucose, plus a weird gum-like organic material, and even ancient stardust. Down on Earth, ribose helps build RNA, and deoxyribose helps build DNA. DNA and RNA are basically life's instruction manuals. They store information the way a hard drive stores files. But before you get too excited, no, finding these sugars on Bennu doesn't mean it had life. But it does mean the building blocks needed to build biology weren't rare or special. They were everywhere, floating around in the early solar system. Scientists have already found ribose before in 2 meteorites that landed on Earth, so it's not totally unusual. All that is cool and totally benign, but Bennu has a scary side too. It isn't likely to hit Earth, but researchers still model it because it has a very small chance of impact in the late 2100s, including around 2182. And if Bennu hit, It wouldn't wipe out dinosaurs again, but it could wreck climate patterns, blast huge regions, and trigger global-level effects, depending on where it struck. Bennu is like the perfect reminder that space can carry both the ingredients of life and the power to erase it. And if you want more reminders like this, space is like a gallery of cool asteroids. Take Ceres, for example, which was first classified as a planet, then demoted to an asteroid, and then promoted to a dwarf planet again. Hey, talk about an identity crisis. One thing is for sure, it's basically the boss of the main asteroid belt between Mars and Jupiter. No matter what label you slap on it, Ceres is a cold ball of rock and ice about 600 miles wide. Living there would feel like surviving on hard mode. Ceres has no substantial atmosphere, so you need a spacesuit just to breathe and to avoid freezing. Daytime temperatures range from about -136 to -28 degrees Fahrenheit, and at night it drops to around -225. But you'd also feel ridiculously light, because Ceres' gravity is only about 3% of Earth's. A 150-pound person would feel like 4.5 pounds there. Ceres is like a failed planet, leftover rubble from the solar system forming, a proto-planet that never fully grew up. NASA's Dawn spacecraft went to see it in 2015 and spotted bright white patches that looked like headlights from some strange spaceships. The biggest one sat inside a massive crater. Scientists thought it might be exposed ice, but it turned out to be sodium carbonate, salty mineral leftovers from briny water that bubbled up and vanished into space. Even crazier, that salty water may still come from a reservoir about 25 miles below the surface, and the activity could still be happening today. Life seems unlikely there, but with water involved, it might have existed in the past. Now this guy, Tutatis, another cool asteroid, has a weird double-lobed dumbbell shape. Instead of smooth spinning, it does this chaotic tumbling motion, like someone tossed a wrench into space and it never stopped flipping over. Scientists think part of the reason for this weird movement is that Tutatis might be two bodies barely touching. That makes it unstable right away. Then gravity shows up and makes it worse. As Tutatis travels through the solar system, the gravitational pull of Earth and even Jupiter can tug on it, messing with its rotation like invisible hands turning it at random. That's what makes it so unpredictable. It's not just spinning, but constantly getting nudged into new motion patterns. The path it takes through space brings it close to Earth, which sounds terrifying, but the even scarier part is the word chaotic. Scientists determine its orbit for the next few centuries, and it won't collide with Earth in the next 6 centuries. But we don't know what can happen after that. So, as you can see, we don't need to be afraid of every asteroid scientists have spotted, but we might have a good reason to fear the ones they haven't seen yet.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown, 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction. and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. Asteroids are a serious, very real danger. Some of them are big enough to cause a lot of trouble if they collide with Earth. One asteroid in particular is making headlines these days. A new study has revealed there's a small chance it could hit our planet during its close flyby in 2029. But the question is unusual. Will the asteroid survive this encounter? Apophis, which got its name from Apep, the Egyptian deity of chaos and disorder, has become one of the most infamous asteroids. Discovered in 2004, this space object is about 1,100 feet wide. It's about the height of the Eiffel Tower in Paris. Because of its size and the close flyby predicted for 2029, astronomers classify Apophis as a potentially hazardous object. Those are asteroids and other space objects that pass close to Earth and are big enough that we really need to pay attention to them. Right now, scientists say the chances of a collision are slim, less than 1 in a billion. So, at the moment, we can probably claim that Earth is out of danger. But the same can't be said about the asteroid itself. When Apophis passes close to Earth in 2029, our planet's gravity is likely to shake it so violently that it may experience something like an earthquake, a cosmic asteroid quake, if you will. The stress from this gravitational force will probably cause parts of the asteroid's surface to crack off and fly into space. And even though this might not be a full-blown disaster, and the asteroid won't fall apart completely, it's very likely to lose some material during the flyby. Some of this debris might just stick around in orbit, while other bits could fly off into deep space. Over time, this catastrophe could affect Apophis's rotation, causing it to spin differently or tilt in a way it hasn't before. And this is a phenomenon scientists are really interested in, because it could teach us a lot about how asteroids react when powerful gravity is pulling on them. Now, let's get back to Earth. Well, we haven't left. Anyway, even though the asteroid isn't big enough to wipe out the planet like the asteroid that destroyed the dinosaurs, it's large enough to cause serious damage to a large city if it ever collided with Earth. It could mess with the climate all over the planet, too. At the moment, it looks like the space rock will sail past Earth at a distance of around 20,000 miles. It's still worryingly close, but far enough to avoid a collision. To put it in perspective, that's less than a tenth of the distance between Earth and the Moon. So while Apophis likely won't hit us, this flyby could still cause problems for some of the satellites orbiting Earth. They will be much closer to Apophis than we are. The key point is that we can't rule out a risk of a collision in a few more years. As Apophis gets closer, astronomers will keep a very close eye on its trajectory to make sure it doesn't veer off course due to the influence of Earth's gravity. In fact, this gravitational pull could actually cause some serious changes to the asteroid itself. Now, even though Apophis is not likely to cause a global disaster if it were to hit Earth, the consequences would still be pretty severe. The impact could destroy an entire city, and the resulting climate changes could mess with food production for years. It wouldn't be an extinction-level event, but it would still be a huge deal. Now, Apophis is not the only asteroid we need to worry about. Scientists are constantly on the lookout for other asteroids that could potentially cause harm to our planet. Thanks to new technology, astronomers can now track dangerous space rocks from way farther out in space. One cool new method they're using involves studying meteor showers. These showers are actually caused by long-period comets that have been orbiting the Sun for hundreds or even thousands of years. As these comets pass by, they leave a trail of dust and debris, which can end up creating meteor showers when Earth passes through them. Scientists analyze the properties of meteor showers, like their speed, direction, and where they come from. This can help them trace the particles back to their parent comet or asteroid. It's actually a big deal, because it means we might be able to spot potentially hazardous asteroids long before they get close to Earth. The upcoming Legacy Survey of Space and Time project, which is being run out of the Vera Rubin Observatory in Chile, is going to help astronomers track these space rocks from even farther away. Astronomers are going to create a detailed map of the sky and the regions where meteor showers are most likely to occur. It'll help them predict which asteroids might become a problem for Earth in the future, giving us plenty of time to prepare or come up with a plan. But even now, there are many space rocks that can potentially cause a lot of trouble to our planet. Let's look at some of them. Here's the asteroid Bennu. Astronomers discovered it in 1999. This carbon-rich rock is about 1,600 feet across. It's the height of the Shanghai World Financial Center. Didn't you know that? At the moment, this asteroid is the greatest threat to Earth that we're aware of. But don't panic yet. The collision won't happen for a long time. In fact, scientists calculate a 0.037% chance, which is about 1 in 2,700, of Bennu striking Earth on September 24, 2182. I won't be around then. If Bennu does hit our planet, the impact would release so much energy that it would be enough to cause massive destruction in a large region. But luckily, it wouldn't wipe out the entire planet. Still, if Bennu hit a city, the consequences could be catastrophic. NASA's OSIRIS-REx spacecraft has recently visited Bennu and returned with samples, so scientists are learning more about this asteroid all the time. The next asteroid is another one to keep an eye on. It was first discovered in 1950, but wasn't seen again until 2000. Right now, scientists say there's a very slim chance, 1 in 34,500, that it could hit Earth on March 16, 2880, 800 years into the future. So, am I worried? Nah. If it did strike, it would release so much energy it could lead to a global catastrophe, potentially wiping out humanity. Or not. Our next asteroid has been discovered only recently. It was spotted in October 2023. It has a very low chance of striking Earth on October 10, 2119. Man, they got it down to the day? Now, if it were to collide with our planet, the impact would release a lot of energy, which would have a devastating effect for large areas. So, while the arrival of this asteroid is a long shot, this asteroid is still worth keeping an eye on. Now, this asteroid is known as a lost asteroid because it hasn't been seen since 2007. No wonder, it has a very uncertain orbit, and we can't predict its movements. NASA says there's a tiny chance, about 1 in 10 million, that it could strike Earth on March 3, 2030. If it did, the energy released would be able to cause huge regional damage. Finally, we've got this space wanderer. On the one hand, it hasn't been seen since 1979. On the other, scientists believe that there's a very low chance that it could hit Earth on December 14, 2113. Mark your calendars. If it did, the impact would cause a lot of damage and devastation, but it would not lead to the end of humanity. Now, in any case, even though the chances of an asteroid hitting Earth are low, the consequences of such an event could be huge. That's why scientists are so focused on studying these space rocks and tracking their movements. Thanks to new technologies, we can track dangerous objects from farther away and catch them earlier. It can give us more time to react and come up with some effective solutions. So, how do you feel about cooking? Nah, pasta and burgers are overrated. How about something more exotic, or rather, more cosmic? So, the recipe is simple. Take a team of enthusiastic astronomers and add some old images from the James Webb Space Telescope. Stir really well, and you'll get a shocking number of tiny asteroids in the asteroid belt between Mars and Jupiter. Yummy! The highlight of this dish is the direction in which some of the asteroids are moving, because in their way, there's our poor planet. Are we doomed just because you decided to cook? Now, the asteroids I'm talking about are much smaller than the massive space rock that wiped out the dinosaurs, but they can still cause considerable damage. They range in size from as small as a bus to as big as a stadium. But even those small ones pack quite a punch. Let's look at a recent dramatic example. It happened on February 15, 2013. A small asteroid just tens of feet wide exploded in an airburst over Chelyabinsk in Siberia, releasing an insane amount of energy. Many people witnessed and recorded the event, and it gave scientists vital clues. New computer models helped scientists reconstruct the size, speed, and impact of the Chelyabinsk meteor. It was likely an asteroid, about the size of a 5-story building, exploding from 15 to 18 miles above Earth's surface with an enormous, incomparable force. The blast shattered 1 million windows and hurt over 1,000 people. Fortunately, it wasn't powerful enough to cause too much damage, but it gave us an idea about how dangerous an airburst can be. Now, an airburst occurs when an object explodes high in the atmosphere, never striking the ground, but releasing enough energy to devastate the area. But back to the small asteroids. The most dangerous thing about them is that they hit the Earth far more often than the larger ones, about 10,000 times more frequently. To make matters worse, their small size makes them harder to detect in advance, leaving little time for preparation if one is heading towards Earth. Now, let's travel back in time. Uh-oh, dinosaurs, too far back. Ah, there we go. A team of astronomers is working on a special method to find small asteroids in telescope images that were originally taken to study distant stars. Using this method, they've looked through thousands of JWST images of a star system called TRAPPIST-1. It's located 40 light-years away and is one of the most studied systems outside our solar system. Now, while analyzing these images, they discovered 138 new asteroids in the main asteroid belt, plus 8 they already knew about. And guess what? Among the newly found asteroids, 6 seem to have been pushed into paths that could bring them closer to Earth. Who did it? Well, probably nearby planets. Are they holding a grudge against Earth? Interestingly, scientists thought they'd find just a few new asteroids, but the number was much higher than they expected. Yet, it's no wonder. Right now, they're exploring a part of space they didn't know much about before. Now, let's talk about the hero of the day, the James Webb Space Telescope. It's especially good at finding small asteroids because it can detect their heat. These asteroids give off infrared radiation, which is much easier to see than the faint sunlight that reflects off their surfaces. This technology allowed scientists to spot the smallest asteroids ever seen in the main asteroid belt. The asteroids they found are pieces left over from collisions between bigger space rocks. Finding them helps astronomers understand the history of the asteroid belt and improve methods for tracking small asteroids that could threaten Earth. The researchers are planning to use James Webb to observe other star systems for at least 500 hours. They expect this work to uncover thousands more small asteroids in the solar system. Other advanced telescopes, like the Vera C. Rubin Observatory in Chile, will also help. Starting in 2025, this observatory will use the world's largest digital camera to photograph the southern sky every night for at least 10 years. Each image will cover a huge area of the sky, about 40 times the size of the full moon. The observatory might find up to 2.5 million asteroids in just 6 months, almost doubling the number we know about. Recently, NASA has identified 2 small asteroids. They were supposed to pass near Earth on December 16, 2024. Luckily, neither posed any danger to our planet. The first asteroid was 71 feet wide, about the size of a large airplane, and was traveling at 10,800 miles per hour. The second asteroid was slightly smaller, 56 feet wide, but it traveled faster at 14,700 miles per hour. But hey, even though this time the danger is past, who knows what the future will bring? It may sound weird these days, but astronomers didn't really care much about small asteroids for a rather long time. They thought of them as just random space debris that got in the way of observing stars. Some even called them sky parasites. But now, the way we see these little space rocks has completely changed. You see, until recently, we could only spot really big asteroids, those over a mile wide. The smaller ones just blended into the background noise in telescope images. But then, a clever trick appeared where multiple images of the same part of the sky were combined, making those faint small objects finally stand out. The data from certain telescopes, along with the James Webb Space Telescope, helps us improve planetary defense. But there's more to it than just protecting our planet. Studying these small asteroids also teaches us about how the solar system evolved. There are so many of them because they're fragments from collisions between bigger space rocks. One researcher has said this is like looking at old data in a new way. These small asteroids, which people used to think of as space junk, are crucial for understanding our solar system and even preparing for whatever the future holds. Among those hundreds of millions of rocks orbiting the Sun in the asteroid belt between Mars and Jupiter, some are especially worrisome. They come close enough to Earth for it to be quite concerning. NASA classifies asteroids that orbit within 30 million miles of our planet as near-Earth objects, and those could pose a serious threat if they were to collide with our planet. Right now, NASA is closely monitoring an asteroid named Bennu. This is a fairly large space rock, measuring about 1,600 feet across. It could, potentially, crash into Earth in 159 years. First, the astronauts spotted it in 1999. So currently, experts believe that there's a small chance Bennu could drift into Earth's orbit and collide with our planet by September 24, 2182. Would it be bad? Well, to put it in perspective, Bennu is taller than the Empire State Building. If it hit Earth, it would generate 1,200 megatons of energy, an amount so massive that nothing on Earth could generate that. NASA scientists are particularly concerned about a tiny chance that Bennu could pass through a gravitational keyhole during a flyby in the 22nd century. This keyhole is a region in space that could set the asteroid on a path that brings it directly to Earth. Now, Bennu flies by Earth every 6 years and has had 3 close encounters with us in 1999, 2005, and 2011. Right now, scientists estimate that the chance of Bennu hitting Earth by 2182 is about 1 in 2,700, more than 5 times greater than the chance of being struck by lightning. Although the chances of Bennu colliding with Earth are very low right now, this space rock is still classified as a potentially hazardous asteroid because it might come as close as 4.65 million miles to Earth. Now, this asteroid is another space rock that we need to keep an eye on. It's a near-Earth object about 1,100 feet across, and it was discovered in 2004. Initially, it was considered one of the most dangerous asteroids ever detected. Apophis quickly gained attention because experts believed it could pose a serious threat to Earth because of its close approach to our planet in 2029. However, after further study of its orbit, astronomers determined that there was no risk of a collision for at least a century. Well, we can all breathe easier now, can't we? A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the Sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the Earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO-Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO-Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the 4th imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9th, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game.